So let's take a closer look at the periodic table. So we've already seen it briefly before, but essentially the periodic table orders all of our elements in terms of their proton numbers. So you can see as you go across the table, the proton number increases, and you can see it goes from 10 over here to 11 over here, and so on. And so what that means, what actually ends up happening is we end up grouping similar elements together. And actually, if you look down the periodic table, then going downwards, these are called groups. So these numbers over here refer to the group number. So this is group 1 containing lithium, sodium, potassium, and so on. Group 2 is then over here. And if you look across the periodic table, then these are what we call periods. So that would be one period. This would be another period, and so on and so forth. Now, we're mostly interested in the group number because the group number actually corresponds to the number of electrons on the outer shell. So here we've got group 1. So this tells us there's one outer shell electron. So if you remember when we drew our electron diagrams to show the electronic arrangement, we had the atoms arranged with their shells like this. And basically for group 1 atoms, then we're saying that they have one outer shell electron. And actually the period that they're in tells you how many shells they have. But the most important thing we want to note here is the fact that in group 1, you're going to have one outer shell electron, and that pattern follows for the rest of the groups as well. So group 2, you have two outer shell electrons, group 3, 4, 5, and so on and so forth. So what this means is that we have similar properties occurring within each group, and we can use that to actually predict the chemical properties of various elements depending on what group they're in. And so, for example, if we know the reaction of sodium, how sodium reacts with a certain other element, let's say water, then what we'll be able to do is actually say, okay, if sodium reacts with water in this way, then we'd also expect potassium to react in a similar way, and same for rubidium and lithium, because they all are in the same group, so they have similar chemical properties due to the fact that they all have one outer shell electron. Okay, so you can extend that idea right throughout the periodic table and use it to actually predict chemical properties of elements. So yeah, let's have a go at a few questions now. And a little quiz for you guys then to see what you remember. So the first question is, what order are the elements arranged in the periodic table? And as usual, pause the video to have a go. So in the periodic table, elements are arranged by their atomic number. Okay, so you can see the atomic number increases. I'll just go across the periodic table. Next question, how many outer shell electrons do elements in group 7 have? So group 7 means there's 7 outer shell electrons. Hopefully we got that from the video. And last one, number 3, name an element in group 0. So group 0, we didn't mention this, but over here you see that this one is labeled group 0. Group 0 is also called group 8 sometimes, and it's also called the noble gases. And essentially these have a full outer shell. So you could say that they have 8 electrons on the outer shell. We call them group 0 or group 8 interchangeably, but essentially they have full outer shells. Okay, so hopefully that was useful, and I'll see you guys in the next one.